In this video, I would like to show you how to program one of these Lattice iStick FPGA development boards with a complete open source toolchain. I have prepared a little Verilog example here. We have our Verilog source file. In this case, this is a little gray counter design, and also a placement constraints file that specifies where the individual pins should go on the iCE40 FPGA chip. So in order to synthesize this to a technology-dependent netlist, we are going to use Yosus. Yosus is a program I wrote. And Yosus can be called with a synthesis script. You can do a lot of interesting things with Yosus, but in this case we only want to do very simple stuff, so we can just specify all the commands on the command line and don't need to write them into a synthesis script file. So first we will read the design and then we will synthesize it for iCE40 and write the results as a BLIF file. So that's it, that's the entire synthesis pass. Now let's just look at the BLIF file. That's what it looks like, that's what has been created here. So we see a couple of LUTs, a couple of carry units, also a few flip-flops. That's all there is. So the next tool is Arachne PNR, that's written by Cotton Seed. And this is a place and route tool for the iCE40 FPGA. So we want to place and route for the 1K chip. We want to use our placement constraints file. We would like to write the results as example.txt, and the netlist is example.blif. So that's the entire place and route step. And this created an example.txt file. Let's just look at this. This is already the bit level configuration for the FPGA. So we have the individual slices here and what bits are set. We can see most of the slices are unused and all bits are set to 0 here. So finally we need to convert this text file into a bitstream file for the FPGA. Here I'm using iCEPAC. That's one of the tools from my iStorm project. Input file is example.txt, output file is example.bin. This created an example.bin file. So the only thing left to do is now to program this bitstream file into the FPGA. There's another tool from iStorm that can be used for this, iCEPROC, example.bin, and I'm now going to hold the FPGA in front of the camera so you can see what happens when I press enter. Now the FPGA is in its reset state. For some reason they decided that in its reset state it should enable the pull-ups, so the LEDs are dimly on at the moment, but now let's program it. And now the gray point counter program is running on the FPGA, and only open source tools have been used to go from the HDL Verilog code to the linking hardware. So I hope you enjoyed this video. I will put links to all the projects in the description. Till next time, bye.